Well, इसका सब्जी बना दो आंटी, इसकी चटनी भी बना दो, पालक का दाल, बाकी सब
थोड़ा थोड़ा चक्का सब्जी भी थोड़ा तो
सब्जी बना दो पूरा।
हाँ कहीं को बोला तो ये फ्राई करना तो थोड़ा होता, अभी इसमें भी दाल डालना पड़ता
हाँ, ठीक है,
होता, सब्जी कम पड़ता। सब्जी भी
Okay, so let's start. You did your speakers, right? You have turned off your speakers, right? Just confirm. Yeah. Okay, fine. So, so yeah. Good morning, guys. So yeah. So in today's session, we'll have a small introduction to generative AI. So basically, yes. So basically, the idea of this particular session is to understand, to go deep dive into the basic idea of what is generative AI. Okay, and we'll do a small use case at the end with by using the OpenAI ChatGPT API. So let's start. Um, so first, before starting with generative AI, understanding about generative AI. So this is the agenda for today, whatever you are seeing on the screen, right? So before starting with generative AI, first we'll start with understanding what is AI, because we'll first understand the AI terminology. I guess most of the people who are already have idea or already doing working on this particular sessions have idea on this. But however, we'll just do a glance on what is AI and all those things, and then we'll compare what is the difference between a traditional AI and the generative AI, and then we'll proceed with understanding more about the generative AI models. Okay, cool. So first thing, what is AI? First thing. So as everyone of AI is all about making machine intelligent, right? That is what we know, correct? So it's all about whatever we have, whatever knowledge we are having, like decision making, or it might be recognition skills, like whatever we do. We as a human, we have all these kinds of knowledge, right? Decision making, recognition, or else for example, communication. So whatever capabilities we are having, right? When you say human intelligence, what is human intelligence on earth? Like decision making, recognition capability, or communication capability, whatever we are having. Now, applying that means like making your machine do this job, right? Making your machine communicate, making your machine to make decisions, making your machine to recognize something. So whatever we are doing, whatever we humans are capable of, like providing that sort of intelligence, okay, making your machine that sort of that intelligent is called as an AI, right? That is what we are mainly working into, right? So basically, AI refers to what? AI refers to a machine behaving like human, mimicking human brain, correct? Mimicking human brain or mimicking human behavior, understanding natural language, understanding understanding what it is seeing surroundings. All right, that is what AI is all about. So any systems which makes machine intelligent, right? Any system which make machine intelligent, we call it as an AI system. I guess every one of you know this point, right? So I guess you got this point, right? AI is just a simple. AI is nothing but making machine intelligent. Now the question here is, if I talk about AI, I should always talk about the branches, right? The branches of AI. So basically, if you see, if I just talk about the branches of AI, so these are the branches of AI. Generally, we always talk about, right? We say it is artificial intelligence, machine learning, deep learning, and here comes a new branch that is called as generative AI, right? So before actually going into this deep dive into this particular branches, means what are these branches all about, or what are these subfields, or what are these fields all about? Means basically these fields are nothing but your way you implement AI, right? So these are the different ways you implement AI. Like machine learning follows one specific way, deep learning follows one specific way, generative AI follows one specific way, and they are actually designed for specific tasks, right? So before talking about this concept of AI branches, right, we'll also talk about how AI works. I guess this part you already know, but then again, I am just discussing about this part again, just to make a small refresh on what exactly we will be doing. So generally, when you say AI model, what happens in AI? So basically, as you know, you'll be having something called as historical data, right? Historical data is one of the important aspect in any kind of AI building process. You should have a data. You should have data. Historical data means a data, right? So that historical data, what you are trying to do, you are trying to feed it to something called as an algorithm, right? Generally, what you do, you will feed this historical data to something called as an algorithm, right? That is what you are doing in machine learning, right? That is what you are doing in deep learning also. What you are doing, whatever historical data you are having, you are feeding to a mathematical algorithm, mathematical system. And what is that algorithm doing? What is that algorithm doing basically? Tell me. What according to you, what is that algorithm doing? Everyone? Anyone? What is the algorithm doing given the data?
Finds it's understandable if I find the pattern in it and
Mhm.
based on that for the future values.
Correct.
Predicts now.
Correct. That is the main idea. No? So the idea is very simple. That is, given the historical data to the algorithm is designed in such a way that it will learn from the given data. It should understand the patterns from the given data, correct? Whatever patterns, whatever what we say, the learnings, the information present in that particular data, it will learn from that particular. The algorithm learns from that particular historical data, right? And once the algorithm is learned, once you have a trained model, we call it as trained system, we call that as an AI model, correct? That's how we generally see the architecture of AI, right? So we'll be having a historical data, right? We're having a historical data. Whenever you feed this historical data to an algorithm is a mathematical model, a mathematical system. Algorithm is nothing but a mathematical system. And this algorithm is designed in such a way that it should learn or understand the patterns present in your data, right? Automatically understand, not manually. See, generally we do manual data analysis. We do EDA. In EDA, what we do? We do manual analysis, right? We apply cross-tab, we apply mean, median mode, we apply skewness, we apply kurtosis, we apply a lot of other analysis we do, and we'll try to understand about the data. But here we are trying to design algorithm here such that the algorithm itself will understand the patterns in the data, and ultimately we will do some tasks. Now, what kind of tasks we are doing through AI? That is what we should learn right now. See, ultimately, when you are trying to design an algorithm to learn from the data, it should do some tasks, right? What kind of tasks we can do with this? That is what we'll be learning. Okay, but that is the idea. The idea is very simple. That is historical data. You are feeding to an algorithm and you're learning from that. Okay, so basically, as you can see the definition also, AI is achieved through use of algorithm and the statistical models that allows machines to learn from the data, right? To learn from the data, adapt to new situations, and improve their performance over time. Obviously, we'll fine tune and improve over time, right? Ultimate goal of AI is to make machine intelligent. That is the main goal. That is a main goal, and solve the complex tasks and solve the real world problems. Correct? Yes, this is what we generally do in AI. Correct? Now, when you come to this, first we talk about data, historical data. What is data? We are saying historical data, right? What is data all about? What is data? What is data? We can say data is nothing but information, right? And information in the form of, how are we feeding the data to the algorithm in general in your machine learning or in deep learning or whatever you are doing right now? How are we feeding the data to the algorithm? Tabular format. Okay, that is one format. Yes. So obviously data is nothing but a set of facts that can be stored, processed, or analyzed. And yes, you are providing the data in tabular format. Correct. Next, any other format? Yes, I can also give an image. Means it should learn from the image, right? It should also. It's not like okay, data will be only having tabular format. It can be an image or a video or a text, right? Text format where it will learn from the text and also from the audio. So these are the different forms of data generally we always explore. Like we only say not only tabular data, not only tabular data. So we will be generally working with text or image or video or audio also, right? Right. That is the idea. So that is the idea of data. Okay. So data can be anything, correct? When you are feeding to the AI algorithm, data can be anything. It can learn from any kind of data. That is our main goal. Correct. Now, this is the branches of AI as we discussed. Different branches we're having, like machine learning, deep learning, generative AI. These are the different branches we're having, which represents, how you implement AI. Okay. So first we'll start with understanding what is machine learning. I guess every one of most of the people here know what is machine learning, right? But we'll just do a refresher because we are trying to compare what is the difference between machine learning, deep learning, and AI, and generative AI specifically. To understand the main tasks, main comparison, right? So when you come to machine learning, so what you do in machine learning according to what exactly you do in machine learning generally? Tell me. Hmm. What kind of algorithms you see in machine learning? What kind of algorithms you see in machine learning? SVM, okay. SVM is one algorithm, correct? Fine. Yeah. Say something.
Based on the model types, supervised and unsupervised.
Okay, yes, supervised or unsupervised, fine. But I just want to ask you, in supervised, unsupervised also works for deep learning. But my question is, like, if it is supervised or unsupervised, what kind of models you're seeing inside that? What type of models? And what are the models as? How the models works here? How the algorithms works basically? Talking about the algorithms. Yeah. Yes, linear regression, logistic regression, and all those things. So now if you see this linear regression, logistic regression, SVM, decision tree, random forest, all these algorithms are based on what? Are based on what? Statistical, like mainly they are basically statistical mathematical techniques, right? You see, for example, linear regression. We are using a concept of linear algebra. Y is equal to mx plus c equation. Or we are using something called as hyperplane equation, which is again based out of linear algebra concept. For example, you are using naive Bayes algorithm. Naive Bayes is based on what? Bayes theorem. You are working with Bayes theorem and you are trying to create. I mean that's again a probabilistic model. Or for example, you are seeing decision tree. And decision tree based on what? Entropy and information gain, correct? So entropy and information gain is again what? It's again a mathematical, because entropy is nothing but again a degree of impurity. You're talking about degree of impurity. It's nothing but you're working with a mathematical equation, right? What is like probability based equation? Entropy is nothing but a probability based equation, correct? So all these models, whatever you are working on, that is your linear regression, it might be logistic regression, SVM. All the SVM is also again based on equation of line, equation of hyperplane. All right. So all these are mathematical models. So machine learning is all about you are having a historical data and you are feeding the data to a mathematical models. What kind of mathematical models? It might be your SVM, linear regression, logistic regression, all these things kind of mathematical model. And what is the task in machine learning? What we want to ultimately do in machine learning? What is the main task? Predict, right? See, of course, it will understand patterns. That's correct. The main idea is in this stage, if you see in this particular stage, it is doing what? It is learning, right? I will say it is learning. But when you say learning, it is understanding the patterns. That's correct. It is understanding the patterns. It is trying to understand about the data. It is understanding the scenarios, different scenarios about the data. But ultimate goal is what? That is doing predictions, right? That is the main goal of machine learning, right? That is the main goal of prediction. The task is what? Ultimately to do, yeah.
There are actually two meanings for predictions. Like basically, in our college time, like we using the Excel data, we will predict the future trends of how like we find the expected values of the future.
Okay.
With respect to this ML model, prediction is like we give the future data and based on the model learning, it gives the output.
We'll give historical data and based on the model learning, we are expecting to predict about the future data.
Future data also we only give, right?
The inputs we give, don't give outputs. New data, we cannot call it as a future data. We can call it as new data, new patterns, new data, which is not unseen by the model. We can say new data. Of course, new data will be always future now. See, if you're already existing data, then we'll add in the train. Why we call it as future? See, now today you'll train. Tomorrow you want to test it. Tomorrow you want to test with new data, which is not, for example, you're doing customer purchase prediction. You're training with existing customers, but tomorrow new customer will come. And that new customer we don't know whether he'll purchase or not. But we are having his personal information, we are having his age, salary, and everything. So based on that, we are trying to predict whether he's purchasing or not. That is our main goal, right?
Machine learning by itself it won't predict for the future value. Only when future data or new data.
The inputs are given, we have to predict the output. That is the important. The input should be given. The model should take the inputs. Without inputs, now we also, let's assume we as human, without knowing the person, can we say the person will purchase the product or not? Without knowing the person, imagine, forget about machine learning. We as human, let's assume we are also intelligent now. That's what we want to make in AI. Now imagine a shopping mall owner. Okay. Now without knowing the person, like what is his purchase behavior, what is salary, or what is his basic idea, basic information, can he predict when he is able to purchase or not? Right? That is what machine is also. So we should provide some information about what we want to predict, like what we want inputs. That is a basic thing, and we expect the output from the model, right? That is the idea. Yeah. So that is the idea. In Excel also you can do this. Actually, in Excel also you can apply the linear regression. I guess you're applying linear regression. Maybe I don't know, or maybe you're applying some inference statistics. Okay, that's fine. But yeah, the task is mainly what in this machine learning part, that is prediction. The idea is it should predict about something. For example, what all different use cases you worked on? If you remember, what are the different use cases you worked on? You can just post in the chat in machine learning or what? Sorry, loan eligibility, correct? Customer churn, correct? So in this case, what we are trying to do, if I just take an example here. Okay. So what exactly we are trying to do here? Basically, we are basically given a data, right, about past. We are trying to learn and try to build a model. And this model, what it is able to do, it is able to, this particular model is trying to take the new customer or new data, not new customer, it can be new data, right? Yeah. So new data, and what we want to do with this new data, we want to predict. Like the use cases which we worked on, right? Like customer churn, where we are trying to predict whether a customer will leave a company or like leave the company or leave the respective telecom or any industry you can consider, or leave a bank or not, like that. Customer churn. We have worked on what? We have worked on loan, loan eligibility. So we are where you are trying to provide the customer data and you are trying to predict whether he is eligible for loan or not, right? Loan eligibility. Right. So these are the different use cases which we have worked on, where we are trying to do what? You are trying to apply a traditional mathematical algorithms, and you are trying to do one task here. The task is what? Either predicting whether the customer will churn or not, or you're predicting whether the customer will get loan or not, right? These are the general tasks we are doing, right? That is the idea of machine learning. Machine learning is all about doing this. Now, how different deep learning is from machine learning? First thing, we should understand that deep learning is a branch of machine learning only, because ultimately inside deep learning also you're applying some mathematical algorithms only, but in more deeper way, in a more higher with higher what we say nodes and neurons, right? So what is deep learning all about? Yeah, what will get replaced here in this deep learning, or what is the change in this deep learning when you say deep learning?
Like not being data.
No, we are working with historical data in deep learning also. For example, here in deep learning, we have implemented one use case called as bank customer churn prediction. That was historical data. We have taken the bank customer data and we have tried to predict. They're also same thing. And we have taken the cats and dogs images. We have taken the past cat, like the general historical cats and dog images, and given a new cat image to predict other cat image, not the existing cat. Of course, you can also provide existing, but yeah, the same thing. Yes, more and more complex, right? Like in machine learning, you're building a simple algorithms, like simple mathematical models, right? But in deep learning, you're building more and more complex algorithms. And what those complex algorithms called as? Neural networks, right? That is the main difference, right? That is the main difference. When you're working with deep learning, when you're working with deep learning, you're just replacing this mathematical model with what? Neural networks. Means the mathematical model itself is a neural network. So you'll be applying a specialized algorithm called as neural network. And whenever you're working with neural network, people call that algorithms as deep learning models. That's it. Okay. Where neural network is complete, and everyone of that deep learning is based out of neural networks, and neural networks is completely based out of human brain, right? It was inspired from the human brain, the concept of neurons and networks and connections. Correct. So basically, that is what we are trying to do. And moreover, everyone of that the deep learning algorithms are mainly designed for what? For complex patterns, for complex data, because the algorithms itself is complex. Because in machine learning, when you're applying a mathematical algorithm, it will be a simple one single mathematical algorithm will be applied. But here you'll be applying kind of multiple mathematical algorithms, group of multiple, more complex structure you're creating, right? With interconnected nodes, we call it as. Yes, obviously. With the deep learning, we can work with larger and larger data sets. That is the main idea of deep learning. You can work with larger data sets, complex use cases, right? Complex problems, complex data, complex data structure. Because sometimes machine learning fails in identifying patterns in complex structures like images or videos or audios or text data. It is difficult for machine learning to identify that pattern. I'm not saying machine learning will not do that. Machine learning can do, but it will be very difficult for especially basic models. So we'll increase the complexity by adding neural networks there, by increasing the, because every one of that this neural networks, in this each neuron is one mathematical model, right? Just you're increasing the complexity of the architecture, right? That is what deep learning is all about. Okay, right. Perfect. So we learned about deep learning and machine learning, and if you observe carefully in the deep learning and machine learning, what is the task we are achieving here in both machine learning and deep learning? Prediction only, right? If you are going for machine learning, you are going for prediction only. Your task is prediction itself, and the deep learning also you're trying to do the prediction itself. For example, what are the use cases which we have worked on deep learning? For example, we worked on bank customer churn prediction. That is also you're trying to predict. Now you're trying to predict whether a customer will leave the bank or not using deep learning. Or we are trying to we worked on this cat and dog prediction, cat and dog analysis, where you're trying to make the model learn from the historical cats and dogs data, right? Cats and dogs images. And whenever you give a new cat image or new dog image, we want to predict whether it's a cat or a dog. Correct? That is our main goal. So they're also prediction only. We are going with prediction itself. Okay. But the only difference is the algorithm is the difference. The algorithm we are using a complex algorithm, right? That is you are using a neural networks. Correct. So that is the difference. Now comes your generative AI. Right? What is generative AI? What is the difference between the deep learning algorithms and generative AI, or machine learning algorithms and generative AI? See, actually, guys, I can say generative AI is a subfield of deep learning itself. Like how deep learning is a subfield of machine learning. Why I am saying deep learning is subfield of machine learning? Because deep learning, again, it's a mathematical algorithm, but more complex way. In the same way, generative AI is a subfield of machine learning, sorry, deep learning itself. What is doing generative AI doing? It is applying more complexity. Like how did we increase the complexity from machine learning to deep learning? By adding more and more algorithms using neural networks. In the generative AI, you are adding more and more neural networks, more and more complex neural networks. That's it. That's the difference. You are increasing the complexity in generative AI. And the main difference in generative AI when you compare it with deep learning is, if you look at this, you'll understand. That is, if you actually look into the generative AI basic idea, same thing. You're having historical data, and here you're having some models like called as transformers and GANs. Okay, I'll talk about this. What is transformers and GANs? Okay, and transformers and GANs are not new things. They're just advanced deep learning models. That's it. Okay, they're deep learning models itself, but they're advanced. Like complex deep learning models. Deep learning itself is complex models. If you're making it more complex, more advanced, that comes with transformers and GANs. Okay, so you'll be having this model. So same thing. Whatever historical data you're having, you're feeding to a complex models, complex architectures called as transformers and GAN. If you look at this architecture, this is the architecture of a transformer. If you see this, okay, this is an architecture of a transformer. I'll come to that slowly. But now this particular architecture, you like when this particular models learn from this historical data, whenever you say Gen AI model or generative AI model, it means that the task is different here. The task is not just prediction; it is to generate content. Generate content. That is the main task here. So in the last traditional AI, whatever we are working on, we call it as traditional AI versus generative AI. That is a new terminology you have to understand. Traditional AI versus generative AI. So in the traditional AI, you are just the task is to do predictions, right? So if someone asks you what is the difference between a generated, like general traditional AI and generative AI, in traditional AI using the algorithms, you are trying to build a model. Using the algorithms, you are trying to build a model which is responsible to do specific predictions, specific tasks, like specific predictions, like prediction of customer churn, or prediction of loan eligibility, or etc., right? Or prediction of demand or sales, or prediction of cat, or prediction of dog, or any kind of image or something. But here it's not like that. Here generating new content, new information from the models. That is what generative AI is. Generative AI is designed in such a way that the models are designed in such a way that it will generate content. Now, what kind of content it will generate? It can be any content. See, first thing we talked about data. Man. Data can be anything, right? Data can be a text. Data can be an image. Data can be an audio. Data can be also a video. So here also, what I'm saying is, a generative AI system can generate a text data. When you say generating content, it's not like only generating text. Like you see ChatGPT or any other models. These are basically what responsible for generating text data. Like given a text, given an input question, you're generating a text. But it's not like only text data, or if you want to generate an image, you can generate images also using Gen AI models. Music, right? Music means audio data, video data also you can generate. Okay, and also if you want tabular data, like if you ask in CSV file, or I want a CSV, I want a tabular information, it can also give you the tabular information. So generative AI is about generating content. As the name says, generative. The term generative came from generation, right? It is generating content, and how it is generating, it is intelligently generating the content, right? So that is the idea. So in the concept of generative AI, if I just talk about the differences between this, you understood this. The task is mainly generating content. Now, if you talk about the main differences here, if I just talk about the main differences here, imagine you're having any kind of traditional model, right? So you'll be having a model here, right? Model here, correct? Imagine it might be a ML model or a DL model. Okay, it can be a machine learning model and DL model. Now, whenever you're having an existing trained model, what you do in general traditional model, you will provide your inputs, right? Whatever you just asked, right? You'll be providing your inputs. Inputs means data, new data. X, we will denote the inputs by X, right? New data. So we can also call it as new data, right? New data, correct? So we'll provide your new data. And what is the output we're expecting? What is the output we're expecting from this? Obviously, the Y. That is the output. Like maybe, for example, it can be a class. Output can be a class like yes or no kind of thing. Or it can be a probability sometimes. Right? Because if you talk about naive base, you'll be getting a probability. Or in your deep learning, you'll be getting, if you apply sigmoid function, you're getting a probability of occurring. Right? Or it can be class, or it can be a probability, or it can be what? Anything. Any number, right? Any number, any numerical number, like regression. In regression, you'll be getting number, any number, etc. So these are the general expectations of this one, either class or probability or number. That's it, right? That is what we expect from the traditional models. Means according to the use case. For example, if you are doing a customer churn prediction, you are trying to do class, like yes or no, yes class or no class. Or if you're doing dogs and class classification, you're expecting dog or a cat class. Okay, or if you're working with any probability model, you're expecting probability, like what are the chances of occurring it's a cat or a dog or something like that. Or if you're doing a regression problem, like you're predicting a profit of a company or a salary of a person, or you're trying to predict the sales of a company or stock price, you're expecting a number, right? These all are predictions. But in your GenAI models, what happens? So same thing here, you'll be having a model. Imagine you're having a trained model. You're trained with transformer, any kind of transformer models, imagine. Okay, imagine you're having a model. So what is happening here? Here, what will be your input actually? Like, sorry, question, right? Generally here, what we do, we give our input data, like new data, like X. X is called as features, right? Here we give something called as features, right? Features, or we call it as independent variables also. Independent variables, and we expect target. This is your target. This is our general traditional AI. Now in this, we provide something called as a question, or we can also call it as a prompt, right? Generally, the technical keyword is what? Prompt. Prompt, or we can say instruction, etc. We provide a prompt or instruction to this particular model, and we are expecting what? A content, right? Some kind of expected content, right? It should generate some content. It should generate some content. Now, what kind of content we're expecting? What kind of, it depends again. It can be some natural language context, like human spoken like content, text data. We can call it as text, or you can expect the image itself as an output, right? File, I don't know. I mean, I guess there is no such ML model right now to generate a file. Image is like a file only. PDF generating model I've not seen till now. You should see.
If you ask document type, this is the document.
But I guess it is not giving it directly. It is giving it like it is using a Python code internally. If you see that, okay, let's take a file only. But actually, what I'll tell you, whenever it's giving a file. If you tried it, you will be getting an option called as analyzing. If you click on that analyzing, you'll write a Python code if you have seen. And in Python code, what it is doing, it is generating an image, and it is collating all the images and creating a file. Embedding in the file. So it is not actually generating a file. It is generating an image. It is generating an image and collating all the images to create a file. So we can also call it as image. So what I'm saying is what it generates. After that, we can see if it generates image, we can also write a Python code to collate all the images. Na? That is what it is also doing internally. Okay, I can say it is code more clearly, file or code, like the code generation task. It will generate code. Code is also like text only, but code generating code, or maybe video generation or audio. So when you're expecting these kind of outputs here, so we're expecting this. It's not a prediction here. You're generating content like text content, like like natural language. NL means natural language content or code. Yes, code exactly code or image or video or audio. So all this comes under your content. We're expecting this. That is the idea of traditional generative AI models. You're giving a prompt or instruction, right? And this prompt can also contain image or a file or something. You can give anything again. So your prompt can contain image, because we are having some many AI models which can take images in. Okay, you can also give image. You can also give text. Generally, we give text. Text is nothing but prompt, and we can also give a video as an input to understand from a video, etc. So that is what we're expecting. We can give it a model, and we're expecting a content. That is the difference between a normal traditional AI and the Gen AI models. Okay, cool. So you can see the differences also. What I just showed you, same thing. So differences between tasks and the idea. Okay, cool. Now that we have understood what is the main difference between traditional AI and the generative AI, now we'll go deep dive into generative AI, and we'll see how this generative AI was raised, what are the type of models we're having, what are the use cases, and also what all things we generally do with generative AI. Okay, cool. So any questions as of now, up to now, from you guys or online? Any questions? Generally, it's not like that, because ML and DL models are such kind of models where we generally, train such a way that we are predicting something, we are predicting a task. But generative AI are advancement of deep learning models, which is designed for generating content tasks. So we don't train a DL model and then we fine tune it for generating content. No, we'll train a model for creating a content itself. Okay. And there again, deep learning models only we'll be using internally, right? Cool. Perfect. Okay, let's continue then. So now, yeah. So before continuing further, also, I should also talk about few things. I guess this part every one of but I'm just revising this again for you. Like whenever you're working with images, because I told you just now, we can generate an image content also, or you can work with image also. We can give image as input also. So that is called as computer vision. Every one of And if you are working with text, it is called as NLP, natural language processing. This so every one of If you are working with human spoken text or human like text, we can call it as NLP. And if you are working with image data, or if you are working with images, there are also image models, image AI models also, which generate images, or you can feed images. That kind of models comes under computer vision and NLP based. Fine. However, once we proceed further, we'll talk about these keywords in a better way. Right. Now, what is so with this one is very important to understand the rise of generative AI. So see, generally, if you see, during before 2010, most of the people were using machine learning models, like whatever you're learning right now, SVM, logistic regression, decision tree, random forest. That is before 2010, right? Generally those models were mostly used up to 2010, 11, like that. Okay, ML models were used in early 2000s and 2010, less than 2010, machine learning models were getting used. Now, slowly in 2010, after 2010 or something like that, slowly deep learning was taking off machine learning. Deep learning was taking off machine learning. Deep learning was performing better than machine learning algorithm because of its complex architecture and because of its learning capability. Deep learning, a lot of people were using deep learning models and all those things. So people were eventually using this both. Slowly in machine learning also, there was one model came into the picture, that is XGBoost. In machine learning, XGBoost, which is based on GBM, right? GBM and XGBoost. These models again, were top notch actually. Then again, people started using XGBoost and GBM in 2011, 12, that range. And then what happens in 2010, in that after 2011, 12, like that, slowly people started understanding about deep learning, and they were implementing a lot of use cases with deep learning. Lot of Google were working a lot of on deep learning use cases. If you have seen Smart Compose by Google, if you have seen this use case where this use case was there from very long back ago, right? This where they were generating the email, or they were trying to predict the next word in the email, or they were trying to do this also this kind of tasks where they were doing this cut. This was released by Google in 2017 itself, where you're trying to predict the various conditions of a person based on the image of retina. Based on the image of retina, they were trying to predict multiple conditions like this. So this was the idea in 2000. After this, then in 2014, there was a model released, one kind of architecture released called as GAN. Okay, GAN stands for Generative Adversarial Network. Adversarial network. Now, I guess you already learned about CNN, correct? CNN, right? What is the main use of CNN? What is the main goal of CNN? What is the main goal of CNN? We have learned about CNN, correct? Yeah. Why we use CNN for? Why we use CNN for? Generally, what kind of data sets specifically? Images, right? Of course, I'm not saying that CNN will not work for non-images data. CNN also works for text data and also works for normal tabular data also. But in 95% of the cases, 98% of the cases, CNN is for images because we're having other models, text and other kind of data. So 98% of the use cases, CNN is for text, sorry, images. Okay, CNN for images. So by using the same CNN itself, same CNN model itself, this GANs were developed actually. So in 2014, in the GAN research paper, what they have implemented is they have implemented two different CNN architectures. In the last session, if you remember, in our last session, last deep learning session, we learned about various CNN architectures, right? AlexNet, VG60 kind of thing. So similar kind of architecture, not exactly VG60, but similar kind of architecture, CNN architecture they have implemented. Okay, and this was the architecture they have proposed. Okay, let me copy this architecture and explain you the basic idea how GANs were working on. Okay, so if you just do this, yeah. So here, if you observe carefully here, okay, I'll just go through the overview. That's it. Okay, fine. Okay, yeah. So if you look at this GANs network generally, okay. So this GAN is basically, if you see, this was having this two networks basically. One is called as generator, and second one is discriminator. Okay, generator and discriminator. Generator was based out of a CNN model. Okay, generator is based out of a CNN model. It's a CNN model. And also discriminator is also CNN model. Both are CNN models only. But how they work, this particular GAN was the first model, very first model, which is responsible for generating content. Especially these GANs were responsible for generating images. In the before rise of generative AI, before rise of ChatGPT, for example, we saw that before the rise of ChatGPT, have you seen this kind of use cases people were developing, like deep fake? This deep fake use cases was before ChatGPT, right? Like people were you have seen, I guess, famous video where this people manipulated, some developers manipulated Obama's video, right? Lot of this kind of videos were manipulated. Deepfake was very famous, and deepfake was better based on GAN, because deepfake, what it is doing, it is generating content. Deepfake is also generating content. Is what it is doing in this case. Deepfake technology is what you are trying to like manipulate whatever existing video they are having, and generating another video out of that. From the existing video, generating another video, a fake video, right? That is based out of GAN. So how GAN was working was, like you were having some real-time data, like real-time examples, images. These are the images actually. These are the real-time images, And if you send these images to a discriminator responsibility is to tell whether the images are correct or wrong. So what happens is, first in the generator, you will send some noise first. In the very first step, you will send some noise. Okay, and generator responsibility is to generate images. Okay, generate images using CNN. It will generate images, and the generated image, carefully observe, the generated image, and also the real image is sent here. Both are sent, and this discriminator is responsible to tell, okay, this image is correct, this image is wrong. Means you'll compare both images. Discriminator responsibility is like a it's like a feedback system, which will compare these both images and will tell it is correct or wrong. And based on that, it will go back and fine tune this generator. Ultimately, this generator responsibility is to generate new images. Okay, based on the real images, based on the existing images, based on existing samples, it should generate new image. It should generate a new image. And how it will generate? First, you'll generate a noise only. The very, like, how do we start random data first? Here also it will generate a random image. The discriminator responsibility is to compare these both images and tell it is correct or wrong, and then come back and fine tune the generator. Ultimately, generator responsibility end of the day is to generate good images. This was the architecture designed for GAN. This is the architecture of GAN, simple architecture of GAN. This was using multiple use cases. What they're doing, I will tell you in my company where we have used GAN for. In my company also we have used GAN. We have used for removing or generating a good image, good document from the bad document, from the noisy document. I'll tell an example. Okay, don't worry. I'll show an example. Okay, generating a clean document, You can see here you're generating a content here. You're generating a clean document from a noisy document. This was a use case which I worked on in my company. And we have used GAN here. Especially we have used architecture called as pix-to-pix GAN. There was one architecture called as pix-to-pix, pixel to pixel, because it is generating pixel to pixel GAN. Right? Now, what happens in this pix-to-pix GAN, or what happens in this use case which I was working on is, I'll tell you. Okay. I'll show an example first. Okay. So in which places, I have used specifically GAN, I'll tell you. Yeah. So you can see this is the data which I've generated for GAN. Okay, this was the real-time data. Now here you can see there is a clean data, and generated images also. This was the generated images by GAN. So first I'll open the clean data. Okay. So here in the clean data, you will be having all the clean document images of different, because I told you now, we are basically in my company, I work on document analysis, document processing, financial documents. Okay. You can see these are all the clean, somewhat clean and neat documents. Okay? Somewhat clean and neat documents. Okay. Now the respective for this particular documents, we'll be having a respective, unclean data. Okay, this is also clean. Somewhere I kept the unclean data. Yeah. Yeah. So something like this, rotated, same data with rotated, like this wrapped. Can you see this? Or like this wrapped, like this rotated, something like this we will have. Okay. You can see all these are unclean, wrapped, like this. Can you see? Lot of wrapping is applied everywhere. Generally, when you're scanning the images, now you'll be getting this kind of conditions, right? If the document is heavily, rotated, or sometimes you might click a picture which is rotated. We cannot stop that, right? So our idea was our product should also work good for scanned images and for this kind of wrapped images also. Our idea. So here what we were trying to do is we were using GAN such a way that given these images, it should wrap it properly. It should make it straight. Given the wrapped image, it should make it straight. It should generate an image. It should generate an image which is proper and neat. such that our models can, I mean, the other models means OCR model for extracting the content will be easy. Because what was happening because of these images is the problem with this kind of images is these images will not work further when you're working with any extraction of, because from this particular data we'll extract text. We'll extract text from this kind of data. Okay, text, and we say we will try to create a layout from this particular data. Now it is difficult to create a layout, or if it is difficult to identify the layout, or difficult to identify extract the text. You can see now this is difficult to understand this text also. And at least with models. That is the reason why we are trying to we were using GAN for this kind of models. Okay, for this kind of data where the data might be wrapped or noisy. Sometimes we'll be having noisy images also. So let me show you. I kept somewhere the noisy images also. Yeah, you can see there are two. You can see there are two folders here: train A and train B. So train A will be having clean images. Ideally, train A should have all the clean images. You can see. No, train A will be having all the non-clean images, and train B will be having all the clean images like this. You can see rotated, wrapped like this, and train B will be having your like this, perfect and clean images. Perfect and clean images. That is idea. And here we were using GAN. So how we were using GAN means our idea is in this. If you look at this architecture which I was showing you, the generator should be responsible for generating. So in generator, we'll be giving the what we say. What is it called? Generator will be giving the wrapped or noisy data. Wrap or noisy data. So generator will take wrap or noisy data, and generator responsibility is what? To clean the data, to make it straight, to make it. If you're having a noisy document, should clean the noisy. It will clean the noise. That is the idea of generator. And the actual removed noise, and actual whatever images were removed, we have removed noise, and wherever which was straight, that was in the real samples. Now, whatever generator has generated, that is obviously generator will generate some image now from the noisy image. That image and the actual without noisy image will be sent to discriminator, and discriminator will compare this both and tell the generator back that okay, you have generated your image is not still straight, still update your weights to become straight. So both your generator and discriminator are learning from the data, and this generator is learning from the weights and trying to improve. That is the idea. So generator will take what? Generator will take a noisy image, or the wrapped image, and this here you'll be having all the proper images. This both will be compared by the discriminator. Okay, an example to show you. Okay, so that's how it works. That's how it works. I guess this was very long back ago. You can see this was in 2021. We were working with this. I mean, actually, in my other laptop, we're having the proper one. But let me show you some examples also. I guess this is the generated images one. These were the generated images by GAN. You can see now. These were the generated images by GAN. You can see this. There were some issues also. If you have seen some issues, I don't know where did I kept it. Okay, fine. But yes, that is the idea. That is the idea. So one example of generating content. So that's how the GAN was. GAN was introduced in 2014. So GAN is one model. GAN is one model, right? But till now, GAN is used for generating images. For generating images. So GAN is one of the generative AI model. Okay, cool. So this is the idea. Okay, this was released in when. So apart from this, there are a lot of use cases which people were using, like deep fake and all those things. If you just search in Google or GAN image, for example, GAN, GAN images, GAN image generation, and if you just search images, lot of people were generating human faces which are not there at all. They were generating human faces which were not there in the real life at all. Okay, these kind of things people were doing. Okay, and this will be really helpful because for example, imagine I want to do any kind of movie ad or something like that, or ad or something like that. Now, instead of paying a huge money to the actor or something, I can generate a fake character which I can use in my ad or somewhere. So a lot of people were doing this. Okay, a lot of people were doing this. You can see an example of how people were actually working with this one. So these are real images, and this is generated images using GAN. Okay, so you can see they are using GAN here for generating these images from the real images, something like that. So they were doing this kind of thing. A lot of changes they have done like this. Yeah. Yeah, that is also one interesting thing. Like, if you are giving a childhood photo, I want to predict how I look after 10 years, after 20 years. That is what people are doing actually. There were a lot of, I've seen a lot of LinkedIn posts on that. I didn't work on that, but I've seen a lot of LinkedIn posts. People were generating, images of their, old grandparents, how they look after some days, after some years, or how did they look in childhood. All these things they were generating. I've seen those. Yeah. These all were use cases of GANs. Okay. From there only, this generative AI started actually. So you can see some examples. Correct. Yes. And of course, deepfake generation is also, part of GAN only. It is again part of GAN. You can see, it is a part of GAN technology itself. Okay, you can see deepfake generation and detection. Apart from that, there is also one interesting model called as pix-to-pix GAN, which I have used personally. Okay, you can also go through this pix-to-pix GAN. This is again same thing. For given an image, it will translate into another image. So you can see this examples. Yeah, you can see. Given a zebra's photo, it is giving zebra and horses. It is transforming. Can you see this? It is transforming a horse into zebra. Something like that. Okay, something like that people are doing. But of course, this is an example here, but it can be implemented in multiple real-time use cases. I told you my use case, now, like modifying editing some photos and all those things. Okay, all these things they are doing. Okay, this is one example. You can see a video also. Or actually, like the zebra. This is again an example of a GAN use case. Okay. So if you want, if you want to go deep dive into GANs, there is something called as GAN research paper. Just, you can just go to the GAN research paper, generative adversarial networks. Okay. You can just understand more about this. I'll just give this link in the chat. So you can just go through that, how it was working, how it is. Basically, it is based off CNN only. So if you understand CNN, this is GAN should be easy for you to understand. It is based out of CNN only. So you can just go through this one. Okay. Okay, I've posted in the chat. Fine. This is regarding the basic idea of GAN. Okay. Cool. Now, after GAN, so people were using GAN. So using GANs, they were doing a lot of this kind of use cases. Funny use cases. Somewhere funny use cases. Somewhere doing real-time use cases like what we were doing in our use case, in our noisy correction use case or graph correction use case. Like this, lot of people were implementing. But slowly, in 2017, Google and Google developers, Google researchers released a research paper called as "Attention is all you need." Okay, attention is all you need. Attention is all you need. Right? That is a research paper by Google, and there they have introduced a model called as transformer models. Okay. From here, there was huge takeoff in the generative AI. Okay. Like in 2017, this was released. Attention, all you need is a paper, research paper. Basically, this transformer is basically a deeper architecture of deep learning. Okay, if you see this multiple layers here in this, these all are neural network architectures itself. If you see already we know that GAN is CNN. GAN is nothing but two CNNs combined. Generator is a CNN, discriminator is also a CNN, responsible for specific tasks. Here, if you see this architecture of transformers, again, this is internal neural networks itself. Neural networks, especially these are, advanced LSTMs neural networks, RNNs and LSTMs. If you see, there is something called as multi-attention. There is something called as feed-forward network, which is again a neural network itself. Okay, multi attention is nothing but an LSTM kind of network, which is inspired from LSTM, not exactly LSTM, but inspired from LSTM network. LSTM is again a neural network algorithm. Okay, LSTM is based on RNN. RNN is based on ANN. So everything is linked here. Okay, so yeah, you can see these all attention layers. So basically, and there is something called as embedding encoding here. Okay, so this is nothing but a transformer architecture, and this architecture mainly, this architecture was mainly designed. Mainly, was designed for for few tasks. Like for example, next word prediction. Next word prediction. Like given a word. For example, if you say how are, you know, for example, if you just simply say how are dash and dash. What is the next word after this? How are you? Maybe question mark. Next word prediction, right? You're trying to predict next word based on the previous words. This was one use case people were using next word prediction. And mainly Transformer was famous for this use case in the starting days, language translation. Many of the language translation was implemented using the transformer language translation. Because language translation is a kind of a generating content only. Because what you're doing in language translation, you're translating from one language to other language, right? You're having a language as input, you're feeding one language, okay? You're feeding one language to a model, to an AI model. And for example, if you are feeding Hindi, imagine you are feeding a Hindi language, you are expecting to, translate into English, right? Actually, we just started working on this model recently only because we were working on some Hindi use cases, Hindi documents. So we have to translate the Hindi text to English. Right now, we are using a pre-trained models, but those models are not working great. So we thought of starting developing our own, but it is still in progress. We have just started, so we should see how it works. But yeah, this kind of models where Hindi language translating into English. Okay, so here this transformers was used a lot in this kind of use cases, language translation. And slowly, people started understanding about started understanding about transformers and all those things, the importance of transformers. And after this transformers, after 2017, this was actually a revolutionary paper because from this only, the NLP and the rise of NLP and the rise of generative AI is, heavily taken off. Okay, so if you want, you can just read out this research paper. However, we will go through this research paper in our regular classes. But yeah, but you can see this research paper. You can just search for attention is all you need. Very, very famous. Okay, this is your research paper. Attention is all you need. And if you look at the view PDF, you can see the research paper. This is the research paper where they talk about the models and all those things. And this was by Google authors, Google research team in 2017. After that, after this rise of the transformers, slowly there were new models coming up called as BERT. BERT was one more famous model. People were using BERT a lot again. Many companies were using BERT. Okay, many companies. In our company also, we have used BERT in one use case for text classification use case. Okay, BERT is one model. People were using a lot before. This is all whatever story I'm telling right now. This story is before ChatGPT. Before the ChatGPT, whatever story I'm telling right now, this is before ChatGPT. Like BERT is before ChatGPT, and slowly in 2019, OpenAI, using this transformer architecture only, they have developed an architecture from this transformer only. They have developed an architecture called as GPT. GPT stands for Generative Pre-trained Transformer. Okay, Generative Pre-trained Transformer. Okay, called as GPT. This was started in 2019, right? By OpenAI. Right? By OpenAI in 2019, this started. So mainly the initial task of GPT was to predict next words. Given a words, it should predict next word. Means, for example, if I say how are you, it should predict what are the next words coming. Or for example, how are, like predict the next words. That was the initial task. And slowly they are extended this task to predict code, predict the next code. For example, in VS Code or somewhere, if you start typing the code, you'll also get the suggestions or predicting the code. That kind of things also they started implementing using
right? No, generate.
Generate. We can say generate. But yeah, predicting next word or generating next word. Okay, so we can call it as generate. Okay, next word prediction and all those things. In 2019, they started GPT, and slowly in GPT in 2000 some, I guess 20 or 21, I guess they have released GPT-2. GPT-2. They are not released to the market actually. These both GPTs they have not released. It was not open sourced. It was only their architecture. Transformer is open source architecture, but GPT and GPT-2 till now it's not open source. It's a closed source model. Okay, but the task is for this only GPT-2. Slowly, Microsoft started investing in OpenAI. Okay, and then from GPT-2 they have developed something called as GPT-3. GPT-3. Okay, and from the GPT-3 they have fine-tuned the GPT-3 only. They have fine-tuned for fine-tuned. Fine-tuned means for means they have updated this like weights for specific tasks. They are mainly fine-tuned for generalized chatting, generalized chat, for the generalized chat, and they have released something called as Chat GPT. So Chat GPT initial model was based on of Chat GPT, sorry, GPT-3. So GPT-3 was the model actually. They have fine-tuned the model for chat specific. Because GPT-3, if you normally use GPT-3 without without fine-tuning, it will only generate the next content, or it will be generating some random data. But they have fine-tuned it for generating text. Given a question, answer. Means they are fine-tuned for question answer. Question answer use case. Means given a question, we should answer the question. Answer. That was the first task. They fine-tuned for this. They fine-tuned this model for that, and they released something called as ChatGPT. So ChatGPT is a fine-tuned model of GPT-3, fine-tuned of GPT-3. And then after that, everyone of GPT-4 released. GPT-4o is running right now, and they are soon planning for GPT-5. Right? That is what GPT-3 and ChatGPT is all about. Okay. After the rise of ChatGPT, right? After the rise of ChatGPT, I guess rest is history. Like a lot of other models were released also by many big companies, big players. Like for example, if you see, and right now GPT and ChatGPT they are basically are closed source models. Means the architecture of this are not open source to us. No one can see the architecture. They can only use through the APIs and everywhere. Okay, but there are already many open source models also. I'll come to that slowly. Okay, but that is a basic story of how the generative AI raised, how this generative AI came into the picture. All right, cool. I'll talk about this. Now coming to the models. After that, what all models are developed? Let's talk about that also. That is very important. So basically, these models can be divided into two parts. One is open sourced, and closed sourced. Closed source, right? Now, open source means which is the architecture is available to everyone. Everyone can see the architecture. Everyone can modify the architecture, fine tune the architecture, modify. I mean, replace things in the architecture, replace the layers and everything in the architecture. So those models are first famous one was Llama by Facebook. Very famous. It was the first famous open source architecture. Llama by Facebook. By Meta. Of course, right? Llama has released multiple versions. Llama 2 was again became very famous. Llama 3 is running right now currently. Llama 3, Llama 3.2, all these versions by different versions. Obviously, they will do different versions. After Llama, the next model, which actually by big player. I'm talking about big players like Google, Microsoft, and everyone. So one more open. I'm talking about open source. Open source means everyone can look into the architecture and modify it. Everyone can download the model in the local. Open source. One more advantage is even though you're not modifying the architecture, you can download this model into your local system and you can host it in your local system. You can use it without the data going away, right? So one more model was Pi 3, Pi 2, and Pi 3 by Microsoft. Yes, Microsoft also have released their own models, right? Pi 3 and Pi 2 by Microsoft. Then also Google came into the picture, Gemma. Actually, Gemini is closed sourced, but from Gemini only they have released one thing called as Gemma, which is open source. Okay, Gemma. These are by big players like Microsoft, Facebook, and this one. But there are also small, medium level companies, not big players. They have also released some models like some famous models like Vicuna. Vicuna is very good actually. I mean, very good for some use cases, not for all use cases. Why am I Vicuna very good? Because I have used Vicuna personally. Vicuna I have used for credit commentary, a use case called as credit commentary, which we were implementing. Next, Vicuna was actually fine-tuned from was fine-tuned model of Llama only. Okay. Then there was from after Vicuna, there was something called as Lava. Lava is again a fine-tuned model of Vicuna itself. Okay. Next, I'm talking about very famous models. I'm not writing all the models here. Then there was something model called as Falcon. Falcon also became famous, top models. And also there is one more model called as uh, Mistral AI, Mistral, etc. I'm writing etc. Because if I go on writing, there are a lot of models actually available in the market. I'll show the list also. There is one interesting, website where you can see all the list. I'll show that list. But these are the few famous models generally, open source models, which you can download these models and use it. Okay. And closed source models are kind of models where, which is, these are not, you cannot download in your local, or this architecture is not available outside, but you can use like an API. Means they'll provide you an API, a link, and you can use that. Whatever question you want to ask, you have to like call the API and ask it. It is an API based. Closed source will be always an API based. Means it is hosted somewhere on the cloud, on someone's cloud. For example, you're having OpenAI's GPT. GPT is a closed source model. Means OpenAI's GPT. What happens in OpenAI's GPT is, if you want to use OpenAI's GPT, you should use the OpenAI's API. So what you do, whatever question you want to ask, you have to call that API and get the answer. And it is hosted in the OpenAI cloud. You're not hosting in your local environment. Okay. So the problem with closed source models is your data can be going outside. For example, if you're having any, what we say, if you're having any, confidential data or important data which should not go outside of your uh, outside of your network, then using closed source models is not suitable for you, because closed source model will be, obviously the data will go outside, and maybe they might be used for training purpose, or ultimately if it is going outside, we don't have any control on that. So a lot of companies, lot of big players who are actually, who do want their data should go out, they will use open source models, or they will host the models in their network only. Okay. GPT or Gemini API. Enterprise applications, or also some in any enterprise applications, or even non-enterprise applications also, there might be some data which is, which don't want to go outside of your, this one Gemini, or AWS. You're having some AWS models. So I don't know the model name. They kept something. Okay, these models, etc. So these are the, closed source are very few, not very huge. We don't use much actually closed. Very few. Mainly the OpenAI and Gemini is what we generally use a lot. Okay, are the closed source models. Okay. Now the question is how to use these models first thing. How do we find out these models? What are the tools we'll be using here? Okay. Generally, guys, whenever you're working with traditional AI, like deep learning or machine learning, what are the general libraries you work on? General libraries and general tools you work on in traditional AI. NumPy, Pandas, Matplotlib, Seaborn, TensorFlow, Keras, Scikit-learn, PyTorch by Facebook, right? Like these are the most famous libraries which we use in regular. In the same way, when you're working with GenAI, there are a lot of famous libraries and packages and tools which you have to use. Okay, one is Olama. Olama. Okay. Olama is nothing but it's a package. It's not a library. It's not a Python library. First thing I want to make it clear. It's not a Python library. It's a package. Okay. It's a package or a software where you can, by using Olama, you can actually host LLMs, or generative AI models. I'll come to LLM. What is LLM? I didn't talk about yet. But we can host generative AI models in your local. Okay. By using Olama. Okay. Means Olama, if you're actually using Olama package, if you give the model name, it will automatically download the model for you, and it will host in your system. So Olama is one of the famous ones. I am using Olama for my use case, because we are hosting in my local. Okay. Next, Olama. Next, Apart from Olama, there is also similar kind of for only that is called as LM Studio. LM Studio. Okay. Which for Windows is very famous for Windows LM Studio because it is like a UI based. Just download LM Studio software and you'll be having a list of models. Download it and host it in your local. Okay. Next, if I'll come to that. What is packages? This is the then libraries. Coming to the libraries, Python libraries. LangChain, very LangChain is one of the important library. We will be using this a lot. Like how do we use scalar, NumPy, Pandas, TensorFlow, Keras. LangChain is one of the famous library for working with generative AI models. LangChain, Hugging Face. In Hugging Face, actually, there is one specific package called as Transformers itself. Or shall I write Transformers? The package name itself is called as Transformers by Hugging Face. By Hugging Face, right? By Hugging Face. Hugging Face is a group actually, it's a community group. So Transformers, you're having something called as LangChain Transformers, Lang Smith, which is again based out of LangChain only. Okay, you know, etc. I'll write etc. because there are a lot of things I don't want to write it. But mainly these are the general, I can write here. There are a lot of other libraries also, like bits and bytes, and also there is library called as AutoPeft, all those things. But let's not write right now. We will be learning about that. But these are the major famous ones. Okay. Now, generally, for traditional AI to find out the data sets, where you'll go to find out the data sets or use cases. Kaggle now. Kaggle was the most famous website for finding out data sets or use cases and all those things. In this, the most famous website for GenAI is Hugging Face itself. Hugging Face is a community group like Kaggle. So in Hugging Face, what happens is you'll be finding out, yeah, cloud also, cloud, something like that. Yeah. Yeah, Hugging Face, yes. Yes, this is the Hugging Face, the famous website. If you want to, work with generative AI, Hugging Face is, a tool for you, a good website for you. If you just go to the Hugging Face here, if you just go to the models first, if I just open the models, you can see these are the different means in Hugging Face. You'll be having a lot of models available also, hosted models. Okay, so if you just go to models, you can see these are the different open source models available for you. You can see, like like trending models here. Okay, Tencent passes. You can see somewhere you're having Llama 3.1 and all those things. I want to see the trending models actually. Yeah. Yeah, trending only. Okay, fine. These are the trending models. Okay. Then you can sort by most downloads. Yeah. So you can see these are the most download models like this. A lot of models are actually there if you just go through this. And if you just go to the data sets, you can see a lot of data sets here, like how do we see in Kaggle, a lot of data sets. Okay, so Hugging Face is like a community group where you can find out a lot of models and a lot of this. And this Transformers library, which we'll be using for implementing generative AI, is by Hugging Face itself. Okay, so if I just go to PyPy, that is your this one, and here if I just search for Transformers, right? Transformers. You can see this is the library which we'll be using. This is a very famous library. Okay, by Hugging Face, right? Hugging Face, part of Hugging Face Transformers. Okay, this is the important library because all your model implementations will be present in Transformers. Okay, library. Next, apart from Transformers, I talked about Olama package, Olama website. So I'll just open this Olama for you, right? However, we'll be learning about all these things further in our further sessions, how to use Olama and all those things. But first, let me open the Olama for you guys. Yeah. Correct. So this is the Olama's website, official website, okay, where you can just basically the use of Olama is you can download and run your models on your local. That is the main goal. You can see get up and running with large language models. Okay, you can run your models on your local. And if you see in top right corner, you can see models list. All the here it will be having all the open source models. Okay, so if you click on models, you can see all the models list here. Okay, Llama 3.2 Vision, this is for image actually. This is for image data, image data. Llama 3.2, Llama 3.1. I just told you all this on Gemma by Google. Okay. Quen by some Alibaba's model, open source model, Alibaba's. Pi 3 by Microsoft, Pi 3.5. All this Mistral, okay, Mistral. This is for Code Gemma. Code Gemma is for generating code by Gemini models only. Like it's part of this one. So you can see Lava. Lava is again a image model, image generation model. You can see these are the list of open source models available for us. You can just simple. It's very easy to use these models also. Very simple. If you just open this model, okay, and if you're having already the Olama installed in your system, you should run this command. That's it. Olama run 3.1 or Olama so and so. It will automatically download and host in your system. That easy is running a LLM or generative AI models using Olama. That is the reason it's very famous. If you see the tags also, there are 93 tags here. There are a lot of models available. What is this 8B, 7TB? I'll tell you. What is this 8TB, 7TB? I'll tell you. I'll come to that slowly. But there are different tags available, and you can run the generative AI models in your local. Okay, we'll be using this kind of tools in our next upcoming sessions. But yeah, this is the idea I just want to introduce it. Yeah.
Because of this huge data set and high computational capability of this tool, can we use those into our
I'm coming to that. You're talking about the computation power, right? Yeah, I'll come to that. Yeah. So see, I'll come to that. I'll come to that in a few minutes. Okay, but good question. Yeah, but yeah, these are the tools now. Now the question here is main important point here is okay. We are saying Olama can be used for running your models in your local, but is your local system, is your system right now, whatever you're using, is capable of running these models, whatever I should? Obviously, no. The answer is no. I mean, at least, see, that is the point here. For every model, guys, first, before talking about this, I should talk about something called as LLMs and LSLMs. I'll talk about that, then I'll talk about the computation power. Okay, I'll come to that. Now that you understood the tools and the basic idea of generative AI, now I'll just talk about the concept of LLMs. Okay. First thing, what is LLMs called? Why it is called as LLMs? What is LLMs? LLM means large language models. Large language models. Right? And also, there is also one more term called as SLM, which is called as small language. Okay. Language models. Now, why they are called as large language model? Why they are called as language models? First thing. See, now I'll just go back to 2 steps backward, whatever we have discussed. In the generative AI, guys, when you're working with generative AI, I already told you that we are working with, what is the basic architecture of generative AI? What happens in generative AI? If I just go back a few steps backward. So what happens, you'll be having a model, and for that particular model, you're giving a prompt or an instruction, right? A prompt or an instruction, a question, something like that. And you're asking to generate a content. And that question will be in text format. Most of the cases prompt. Of course, you can give an image, but again, you have to give an instruction on that image. And you're expecting a text or an image or a any kind of things to generate. So most of the cases, in this case, it will be a language model. Why it is called as language model? Because it is using the human spoken language to work on. Because you take any model, whatever I showed you right now, whatever models I showed you in this list, in this Olama's list, this one, these are all the models. All these models are the language models. Okay, all these models are language models. Language models means what? It is taking the language, human spoken text as the input and returning text or image as output or audio or all the whatever we need, right? That is the language models. And one more importantly, language models was NLP based models. NLP means what? Natural language processing. Natural language processing means what? Understanding human spoken text. Understanding human spoken language is like natural language. No? In the same way, this LLM, that is large language models, language model means understanding human spoken text. That is what ChatGPT is doing. No? That is what your other Gemini or Google's Copilot and everything is doing. Correct. So the same thing here also. Sorry, Microsoft Copilot and everything is doing. So here also language models means language, understanding language. Now, why it is called as large? Because I'll ask a question to you. You're working on deep learning. If you have worked on deep learning, you have seen the neurons, right? The neurons. In the neurons, can you tell me what are the number of neurons you have chosen when you're working with your architectures, number of neurons you have chosen in your previous sessions. Anyone remember? In CNN or in the ANN which you have worked on, what are the number of neurons you have used generally? 30, 64 in layers, right? 30, 60. In CNN, how many neurons we have used? In the hidden layer, you remember? Last session? Some 200 neurons, 300 neurons, correct. We have also explored about an architecture called as VG16. In that, there are some better neurons, like more number of neurons. Like, 4096, like 4000 neurons. Remember, in the hidden layers we added VG16. And in the filters, we have added some like 200 filters or 50 filters we have added, something like that. All these filters and all these neurons will be having weights, correct? Every one of will be having these weights, correct? Yes or no? Will be having these weights. These neurons or this CNN also in the convolution also will be having those filters, and each filter value is a weight, as we discussed already. So they'll be having weights. Now, when you are training a model, when you are seeing the summary, you'll be getting number of weights you're having. Have you seen anything? Let me show you. If I just go back to the, if I just go to the code. Okay. The people who are not having idea of deep learning is no issue. I'll just explain you the basic idea. First, let me show you this. If I just open this. Yeah. Yeah. So if you remember this use case which you're working on, any use case. For example, last session we were working on V16 architecture. If you look at this, can you see this? Right? This is nothing but what? The number of trainable parameters, means the number of weights we are having, right? So this is very important to understand. This number of weights means weight is nothing but what? The learning parameters, weights and biases. They are learning parameters of a neural network. This is very important to understand. This define whether your model is large or small, right? So now in this, how many parameters we're having approximately around? How many parameters approximately? Something like that, right? Now, do you know how many parameters that GPT-3 is having? How many parameters? Like we are having this many parameters now for our model. Like how many parameters is your GPT-3 is having? GPT-3 175 billion parameter. Means you're having 175 weights and biases, 175 billion weights and biases to learn. You can see now it is feeling large, it's feeling huge. That is the reason it's called as large language. Large language models because they're working on language. And why it is called as large? Because they'll be working on so many parameters, billions of parameters, billions of parameters. 175 billion is GPT-3, right? And so this billion talks about the number of parameters, and which is very important to understand. That tells us how good is your model, how heavy is your model, how large is your model, how large is your model. This 175 billion, or there are a lot of other models which is 200 billion, 300 billion also. GPT-4, I guess it is around 250. I'm not sure, but GPT-4 is around 250 or something, 250 billion parameters models. Okay, so like that, why they are called large? Because of this reason. Large indicates more number of parameters. Means large indicates more number of parameters to learn. More number of parameters to learn. More number of parameters to learn. More number of weights and biases to learn. Because I told you already, generative AI models is all about deep learning only. It's an advanced deep learning mechanism. I told you already that we'll be having neural networks internally. You'll be having advanced neural networks. And those advanced neural networks, weights and biases, if you see the count of weights and biases, that is large. And for training this kind of large language models, a simple CPU would not be enough, and a simple GPU also would not be enough. Okay, you need a high level GPUs for this. You need a high level. I'm talking about these huge models. You need a high level GPUs to use these models, train these models and all these things, right? So 175 billion is very huge. We cannot work on this. That is the reason if you look at the Olamas here, you're having some tags here. This is the Olamas website. If I just open this model, you can see there are some tags here. If you open these tags, you can see 11 billion. 11B stands for 11 billion. So we are working with 11 billion parameter model. So if you're having more better GPU, you can go for 90 billion parameter models. Okay, so they provide both versions, 11 billion and 90 billion. So if you see, they say the same thing. Llama 3 to vision is collection of instruction tuned images reasoning. Okay, in 11 billion, 90 billion, 90 billion sizes. If you look at Llama 3.1, Llama 3.1 has three versions. You can see Llama 3.1 has three versions: 8 billion parameter model, 70 billion parameter model, and 405 billion parameter model also. Okay, depending upon your compatibility, depending upon your GPU, you should download the expected model and put it. Okay, that is the idea. Now coming to the requirement, how much requirement we require for this one? First thing, to load any large language models, to load any LLM models, we at least require a GPU. Without GPU, it is difficult. CPU, it is difficult to load. It will take a lot of time to do the predictions, to generate content, basically, to do the inferencing. To generate content will take a lot of time if you go for CPU based. If you want to go for generally in GPU based, I'm talking about open source models. What happens is, if you are working with 8 billion parameter model, at least your GPU should be approximately at least 8 GB. 8 GB minimum. Okay, your GB should be your GPU. I'm talking about GPU memory. GPU RAM, I'm talking about GPU RAM. I'm talking about GPU RAM, at least 8 GB. And for 13 billion parameter model, around 12 GB of RAM would be enough. Means, see, I'm telling this RAM considering the extra space and everything. See, when you use this minimum RAM, there will be some 1 GB, 2 GB extra remaining. Okay. For example, if you are using a 13 billion parameter model in a 12 GB RAM, what happens is some 11 GB will be occupied by the 11 GB, 10.8 to 11 GB will be occupied by the model. Okay, and whatever I'm telling right now is not for training, guys. This is only for inferencing. Only for inferencing, only for generating content. For training, it requires large. Okay, but don't worry, there are a lot of techniques introduced right now called as Clora and LoRa, which is actually making the training also more faster. I mean, less memory intensive. I'll come to that later on. I don't want to talk about that right now. But this is only for inferencing. Only for inferencing means only for generating content. Only for predicting, we can say. Only for prediction of text or generating content. Yeah, for 13 billion parameter model. So you can only just estimate like how much GB of RAM I require for loading a 175 billion parameter model. Okay, and I also tell the cost to make you understand like how costly is loading a GPU. I mean, loading a LLM model. But don't worry, we will make it more better. But I'm telling you the cost also for 12 GB. NVIDIA's NVIDIA GPU. There is a version called as right now, the latest version called as 40x version. Okay, so for 12 GB, it is approximately costing around for 12 GB of RAM, it will cost around some 1.8 lakhs, I guess. Yeah, 1.8 lakhs for entire, not for only GPU, for entire GPU plus system and everything, around 1.8 lakhs. Recently, I got a quotation. Actually, we were planning to purchase a GPU. So for 16 GB NVIDIA's 4080, we were using 4080 version. 4080 version is a NVIDIA's GPU. The quotation was around, this quotation we got for around 2.8 lakhs. And for 24 GB, it was around 3.3 or something, 3.3 lakhs. Okay, 24 GB is one version is called as 4090. And one more important thing, for a local GPU, for a consumer like you, me, and everyone, consumer means individual, maximum GPU available is 24 GB for local. You can use cloud, someone's cloud you can use and you can host your GPU. But local GPU, if you want to purchase a GPU system, maximum is 24 GB, and the best version is 4090, right? Of course, maybe in future you'll be getting more GPU compatibility. The maximum availability of GPU is 24 GB of GPU. Okay, 24 GB of GPU. Now the question is, yeah, of course, the fact here is, for using LLMs, I'm talking about open source LLMs, right? I'm talking about open source LLMs which you want to host in your system. It will take this much of memory and this much of money. However, no need to worry about this. There are also many free spaces provided by a lot of people. Free spaces, like for example, Google Colab, they provide 15 GB of GPU for free for some time, like I guess for 4 hours or 5 hours, 15 GB of GPU. So we can use it for learning purpose. For learning purpose, no need to worry about all these things. But in real time, when you want to go to a company and do something, these are the computations required. Okay, that is the point. For learning purpose, no need to worry. We'll be having a lot of free things available for us for learning. We'll be using that. Okay, no need to worry about that. Fine. Let's continue then. So then, we understood about LLMs now. So what is LLMs all about? LLMs is all about large language models. They're responsible for what? Why they are called as large? See, I'm not telling that LLMs is nothing. LLMs is the only models which only take text and give us text as output. No, LLMs are models which can take text and give as image output, take text and give video as output, take text and give audio as output, take text and give text as output. Anything. All are LLMs only, large language models which understand language and gives us the language. Okay, got it. So that is the idea. So you can see it's a type of model which refers to generating large amount of text data or image data, or it understand text and generate human like text and all those things. Okay, examples also you can see, these are LLMs. Fine. So this is the basic idea of what is LLMs and what is generative AI. Also, if you look at the use cases, I guess I don't need to talk about the use cases because you have seen in real time many use cases. If you see, so I'm just showing one picture which shows you all the use cases. So you can just go through this picture, which shows all the different use cases used by different people in generative AI. For example, for generating code, I guess many people are using in companies also code for generating code. And recently, Sundar Pichai told that approximately 25% of Google code is right now generated by AI. Right? Call center assistants, right? Code generation, creative scripting, healthcare, scientific research. These are different use cases developed by different people, for working with generative AI. And if you see one generalized use cases, if you see, like it can do visual content generation, audio generation, text generation, and also code generation, right? Simple. In a single picture, you can see what is the main use of generative AI, the applications of the generative AI. Okay, cool. So now that you got an understanding of what is LLMs, what is generative AI, and also you understood what is open source models, what is closed source models, different ways, and also different types of models. I'll explain once. It will not take much time. I guess we already talked about this. So types of generative models means text to text. It takes text and gives output as text. Example is ChatGPT, right? ChatGPT or Llama. Llama is also same thing. Llama to vision is again different. Llama to vision is for taking text and give us output, image as output. But if a model takes text as output and give the text as input and output, that is called as text to text models. And you're having text to image also, text to image, where it takes the text, a prompt kind of thing, and gives us the image. For example, look at this prompt. Look at this text here. Okay, where it says cat sitting on a computer desk with a laptop next to it. So if we want an image like this, and it is generating a content, generating an image on it, right? So I just gave a link here. I'll just share this link also. So this is having a code. We can go through this code. However, we'll deal with this code in our later part of our sessions. But just want to show you. I mean, you can just explore this. In this code, basically, we'll be having stable diffusion. Stable diffusion is one of the model. Stable diffusion is also one of the model for generating images. And there is an OpenAI library like model called as DALL-E. Like how do we see ChatGPT? There is a OpenAI model called as DALL-E for generating images. So you can use that. So I'll show an example here. If I just go to search for DALL-E, so you can see if I just open this, you can see it can generate these images. You can see how it is generating images. Different examples of generating images. Okay, fine. So you can see this is one example which generate images. Okay, so you can see this is an example. DALL-E is one model. Okay, stable diffusion. Yeah, stable diffusion is loaded. Now this is a code actually. If you see, they are giving prompt here. You can see dark eye contrast render from a psychology of life or something like that. So you can see they have generated this image. This is a AI generated image. One more example of AI generated image to image, text to image models, and this is a stable diffusion model. It is using OpenAI's API for this. You can see it is using the OpenAI API for this generating the image. So you can see some examples of how this image is generated. Okay, you can just go through this, all the generated images. Great, fine. So this is an example of how this text to image works, and also there is image text to video models also. Right now they're working on this, not completely developed, but in the research phase, where given a text, for example, a person jogging through a lush green park on a sunny sunshine zone. So it is generating that kind of video when you pass through a letter. That's it. So you can see some examples also. One company working on this. You can see these all are the prompts used and the respective video generated. Right? Prompts used and respective video generated. Lots of examples here you can see, and one more example is make video for studio. So if I just go to this example, also similar way you can see a lot of examples where people are actually generating video based on the text. So like that, there are different video, and obviously text to audio also is there, text to music generation LLMs. Okay, so everywhere you can see the input is text or image. You can also give text or image as an input. Okay, and you are expecting a text as output. Okay, these are different types of models. Actually, they are not limited to. There are a lot of other models, but these are very some models available. Okay, and obviously, guys, when you are working with LLMs, one important point you have to keep in mind is prompt engineering. There is a concept called as prompt engineering, which we'll be talking about that later on. But what is prompt engineering is all about? See, you're expecting text from the model, or expecting the image from the model, or expecting the video from the model. You're expecting some content from the model. Your model should generate some content, generative AI model. Prompt engineering is nothing but prompt means what? Prompt is nothing but the input given to the model. So whenever you're giving a prompt, we are expecting we have to give a prompt such a way that the AI understands it. The AI actually learns, understands every aspect of your requirement and give it. So prompt is nothing but arranging your input such a way that your model understand that particular input and give you the respective reply. That is what prompt engineering is all about. You might think it is very simple. Just giving the input now, you might think it is very simple, but making the AI understandable is difficult. I'll tell you with my experience only, because you'll think that okay, I'll ask some questions, it'll give me a reply. No, there is a lot of fine tuning you should do in prompt only. We have to do a lot of fine tuning in the prompt only to give the result. Okay, so I'll just show an example actually, which I was working on. I guess I should have this. I don't know whether I'm having this or not. One API which I've hosted actually. Okay, I guess that is not available. But I was working on one SQL generator content. SQL query generator for LLM. There I have fine tuned for 2 to 3 days. Prompt fine tuning I've done. Where I've modified some things, added something, modified some things to make the output better based on the results and everything. So prompt fine tuning and prompt engineering is one of the important aspects. I guess everyone remember this scene, right? This is an example of how prompt engineering is very important, right? What happened in this scene actually, if you know what happened in this scene, like the robot, the AI system was misguided actually, correct? Remember the scene from Robo movie, right? What happened here actually? The robot was misguided. The AI system was misguided, right? It was asked to actually turn on the TV, but the prompt was not proper there. Instead of turning on the TV, something like this, something like that. It was something like that. So what happened? It actually, the robo has broke the TV, has broke the TV because the prompt was not proper. So that is what the importance of prompt is. Prompt engineering is what that is why important is. Okay, where your prompt, whatever input you are giving, it should be reliable, it should be correct. Okay, it's not like it's like, even though it's a natural language, still lot of things your AI doesn't know because it's not in the real life. is still in the artificial system, right? That is the importance of prompt engineering. So we will be learning about this. I just introduced what is prompt engineering, but however, we'll go deep dive into this. A lot of there are a lot of techniques for prompt engineering also. Like some examples, like if I say zero-shot prompting, one-shot prompting, two-shot prompting, chain of thought prompting. There are different types of prompt engineering techniques, which which will be helping the model learn better and understand better about your prompt. Not only training your model, giving the input to your model is also very important in this concept of generative AI. Okay, so I hope you got the idea, right? Is this clear? Any questions as of now before going to the use case? I'll just show a sample glance of a use case, which will be helping you to understand this concept. But any questions as of now in whatever we have discussed, please let me know. Anyone? Let me know.
Can architecture. There is a condition right from discriminator.
Discriminator, yes. Yes.
So what actually we use there?
CNN, but specialized CNN. Not a regular CNN, but CNN with some, in CNN what we do, we have convolution layers and then we are having a output layer for probability. So here also in discriminator, we will be having, in generator will not be having output layer as probability. That is very important. Okay, just
about the conditioning.
Condition is nothing but your probability. Probability means the like what is the probability that this is correct or wrong. CNN only. CNN attached with softmax layer. Sorry, your sigmoid layer. Sigmoid layer will return probability. Same thing. There is no new thing in that.
All 3 blocks of CNN.
2 blocks.
Conditioner
is inside the discriminator only. Inside CNN model, I just wrote a condition to make you understand. But this condition, whatever we wrote, is inside the CNN model. Inside the where is this? Yes. Somewhere I kept this now. Here. Yeah.
So use neural networks.
Yes. Neural networks. Neural networks. Transformer is a neural network. Advanced neural network. GAN is a neural network. CNN. BERT is a neural network. All the models what I showed you, all are based out of neural networks. Deep, advanced deep learning, I can say. Not basic ANN what we developed, more advanced and more advanced. Yeah. This condition, yes, that's right. So this condition is nothing but is inside discriminator. Inside discriminator, you'll be having one sigmoid layer in the last which tells whether it's correct or wrong. Okay, which is trained in that way. Okay, yeah. So you're having 2 blocks only, one discriminator, one generator. Both are CNNs. Okay. Then because this takes image as input, okay. Then one more thing, what I want to show you. Yes, use case. So any other questions, anyone, before going to the use case? Like neural network is a base for them. Like how machine learning is based for deep learning, neural networks is based for them, for these kind of models. Correct. Exactly. Yeah.
In next to that, we discuss academic perspective. So usually we check the academic integrity part for any research paper or anything like that. We check for plagiarism.
Plagiarism, yeah.
So like this generative AI model, trains so much that person or student is writing something, and if we check the plagiarism score for that, we get to see that some of the content are created by AI. So even though student has not done such thing. Yeah. So how can we tackle this? Like okay. AI is owning all the information so far available through training or learning generatively. So how can we tackle that problem actually? Even if we are not using plagiarism, the contents are getting matched with AI generated
got it. Content. So actually, I want to show one project based on that only. In Kaggle, we are having that project actually, whatever you're talking about. Yes, we should have that. Let me check. Okay, so recently I've seen this kind of use case only in Kaggle. So what they are trying to do is to identify whether that is an AI generated text or the human generated text. There is other models are built actually. Other AI models are built. Again, we are using the help of AI itself here also. Kind of thing. So what they are doing is they are giving some examples of AI text and the human text. And it's like a kind of a probabilistic model only. Like, this is AI text or human text. Yes or no, like that. Okay. So that is the idea. It should classify. Given a text, like you have learned about sentiment analysis. Now, given a text, you should classify yes or no, like the positive sentiment or negative sentiment. In the same way, they are building models. In Kaggle, I've seen that. Okay. I guess there is some competition going on, if I'm not wrong. I've seen it few days back only. But the same thing, it was working on the same use case where it was trying to estimate whether the text is human text or the machine text. So like that, we can use that kind of, one model which identifies that. And also, one more important thing is, like human-like text, even though, we are good at grammar and everywhere, somewhere we will be doing mistakes while writing text. But machines are not like that. At least they give a proper text with good grammar. That all things we have. If you are even able to identify that, okay, fine. If you imagine you are not able to identify that, then you should develop an AI model which can discriminate this both text. And also there are models. This same question, I'll rephrase this question for you. Not only text, even in your this become a very serious problem in social media also. We don't know what is the real content, what is the fake content because of deepfake technology. Sometimes a lot of fake content you will see online. So there are also a lot of research going on this to identify what is the fake content, what is the real content, what is the fake image, what is the real image, something like that. Okay, they are trying to use some kind of generally how the real image looks, how the fake content generated. If you go further into that, like in text, you go to grammar, grammar and sentence formation, human sentence formation versus AI sentence formation. In the same way, in images, you'll go to pixel level analysis to identify, it is a fake content or a real content. So there's a research going on that also. So let's see. But yeah, that is a problem actually. Even in the deep fake technology also, that is a problem. Yeah. Some questions. See, business intelligence is all about data analysis. Okay, what you do in business intelligence concept. You apply some analysis, you apply some models to improve your business. Ultimately, it is aligned to generate some information, to get some insights, not generate, but get some insights, such that it will be helping you to improve your business. And what is ChatGPT doing? ChatGPT's use case is different. ChatGPT use case itself is to generate text data or generate image data. Now, can you use ChatGPT for business intelligence? Yes, we can use ChatGPT for business intelligence. If you give a data to the ChatGPT and tell that, okay, this is my company data, what I can do to my company, what decisions I can take to improve my company. Maybe ChatGPT can answer, okay, these are according to the data, you can just make these decisions. So ChatGPT can be used for business intelligence. Okay, ChatGPT can be used for business intelligence. What is business intelligence? Like getting some insights, getting some, doing some analysis to your data to improve your business, to make your business better. Okay. Yeah. Any other questions, anyone? Any other questions?
The other is would be implemented based on those data.
Yes, correct.
In our meetings.
Yes. Yes. Correct.
NVIDIA, whatever.
Yes, correct. With those GPUs only. Again, whatever GPUs I've introduced, it is only for prediction purpose, only for inferencing purpose. For training, you need more better GPUs. From training from scratch. However, there is a concept of fine-tuning in LLMs. Fine-tuning means modifying the existing LLMs to make it better for your use case. There, these basic GPUs are enough. These basic GPUs, whatever 24 GB, 12 GB, 13 GB, whatever it is, that is enough for fine-tuning the models. Or training basic models is enough. Basic LLMs with 8 billion parameter or 12 billion parameter models, those are enough. But if you are going to large extent, if you want to train the model completely from scratch, you need a very, very good GPU, like 80 GB, 100 GB of RAM you need, which is not available for open source. I mean, not available for consumer. You have to use like a cloud. Because I'll tell you the cost of 80 GB GPU. Cost of 80 GB GPU itself around some 25 to 30 lakhs. Yeah. So it is not available for the general consumer. If you want to use that models, you have to use some cloud hosted environments, and you have to deploy and use the models there. That's how it works. AWS or only AWS is very costly. They're also very famous, I'll tell you. Where you can rent GPUs. Like there is something called as vast.ai. Vast.ai. So this is one website where you can rent GPUs. If you just see the pricing, there is you can rent a GPU here. You can see hourly pricing, and you can see this one. These are very large GPUs. They are very large GPUs. These GPUs are mostly used for H100 is one of the famous GPUs used for training and fine tuning LLMs. And also there are a lot of other GPU other websites also. If you just search for rent GPU in Google, you'll be getting that. Okay. Yeah. RunPod is also famous. Vast.ai. Nibesis, this is also very famous again. A lot of people are using this for renting GPUs. Of course, Google Cloud already we are having. Yeah. So yes. So like this, you can rent and use it. Okay.
You can purchase also about picture.
I told you now, 24 up to 24 GB physical purchase available. 24 GB 4090. Beyond that, I guess you should have some license or something, some data center license, according to my knowledge. Up to 24 GB of RAM. 24 GB of GPU RAM.
Small amount of data.
So yeah, that is where your small language models will come into the picture, SLMs. So we can use that. Like BERT is a small language model. T5, small. There are some small language models. You can use that. Few small language models. But if you want to go with large language models, then obviously we need this GPUs.
I don't know.
Ulama, yeah, Ulama. Yeah.
Even the LLMs also feasible.
But if you want to use Olama, this is Olama only. I have just opened it. So this Olama is actually, using this Olama, you can load your model into a system, but your system should be capable of that. This Olama is using the package which will be helping us to download the model and run your system, but it will use your system resources. Okay, so yeah. Okay, so that is the idea. Yeah, what I told you, Vast.ai or all the other places. Hugging Face also provides some spaces. In Hugging Face also you can actually use you can load your models actually for some free, sometimes free, and some pricing. So you should check out that. Cool. So now that you got a basic idea, so before closing, I will just show a use case for you guys. Okay, a PDF bot kind of thing. Okay, so let me open this. I'll be sharing this code later on, but just have a look into this. So here what I'm doing, I'll tell you. Okay. Here I'm using OpenAI library and OpenAI's ChatGPT. Okay, GPT 3.5 Turbo, basically GPT 3.5 Turbo. And what I'm trying to do here is I'm using a closed source model. I'm not using open source model right now, because right now I don't have GPU in my system, and I'm not going with open source as of now. I'm not going with any open source LLM. I'm not loading on my local right now. I'm using a closed source model, that is GPT 3.5, by using the GPT OpenAI API. So what I'm doing first, here I've developed a simple UI. Okay, so first I'll run this application and show you how it looks. Okay, and then after that I will show you the code. I will explain the code what I wrote here. Okay, so first let me launch the application. Obviously, to launch the application, it's a Streamlit based application. So you can simply say Streamlit, run app.py. Okay, so if you do Streamlit run app.py, it will launch the app. Yeah. So it is launching the app. So here, what happens here is, yeah. So it's a PDF bot kind of thing, where what is this bot means? Given a PDF, okay. This particular code extracts the PDF, extract the text from the PDF, and that text is sent to the OpenAI's ChatGPT, like using Python, and you're asking some questions about the PDF. You can ask any questions about the PDF. It's like asking questions. For example, if your PDF is having lots of information, okay. So if you want to ask some questions about the PDF, you can use this tool. I mean, use this code. Okay. Any questions? Like it can be your, for example, it might be kind of a question paper summary, or we're having a question paper with you, PDF in the form of PDF format. Give to this, ask questions about the question paper, something like that. Okay. So I'll give some random PDF first. So I'll download some random PDF. I just opened one paper now, research paper. Maybe I'll try to give that only. This attention all is you need. I'll just give that only. Let me download this paper. Yeah. I'll just make this paper as okay. Correct. So now let's see. I've downloaded the paper. Now what happens is I'll upload this. So I'll click on browse files and I'll just select the paper here. Whatever you can apply any PDF. So I'm just giving this transformers.pdf itself. Click on open. Okay, it will download. Okay, PDF uploaded and the content extracted. You can start asking questions. Okay, this is a simple print statement I'm doing, and then I can ask questions about the PDF content. Any questions? Okay, so what happens in this way is whatever PDF you generated, that PDF along with the content along with the question will be going to ChatGPT. That is a GPT 3.5 API, OpenAI API, and it will generate the content and give us. Okay, now how to get the API and all those things I'll tell you, but first let's see the output how it looks. So I'll just say, oh, what do you understand about the extracted content? Okay, so let's see what happens, what it says. Okay, let's wait. Yeah. So what do you understand about the extracted content? So it says, this provided content is from the research paper, right? That is research paper only we uploaded. So about titled attention is all you need, but so and by so and so people. These papers introduce a new network architecture called as transformer, right? So you can see by just giving the research paper, it is giving all the insights about the research paper. Okay, so which is based slowly on the attention mechanism, eliminating the need of recurrent or convolution layers, right? The transformer model shows the superior performance. Okay, so and so and so and so and so. You can see, I told you already, the transformers was initially was for language translation. You can see that is what it says. English to German, German to English to French. I told you already. Transformer was introduced for language translation task. It is giving that information to us. Okay. Now I'll just ask. Okay, explain me the transformer. Now this is what prompt is all about, right? Transformer architecture in a simple way, like to a kid or something like that. Okay, let's see what it says, right? So let's see. So because we have given the context here, that is content. So let's see whether it can explain or not. Okay. Yeah, the question, yeah, it is in the bottom. Okay, explain me the question, then you can see. Sure. So imagine you're having a storybook. So you can start with storybook like this, like explaining like a kid, because I told you to explain to a kid, right? So it says, sure, imagine a storybook with different chapters. Each chapter has beginning, middle, and end. The transformer is like a magic book that tells a story, but instead reading one word at a time like a normal book. Reading one word at a time like a normal book. It can be seeing all the pages. Okay. So transformer has main parts, encoder, decoder. Yes, it explained that. Yeah. So like this, you can go on asking questions about the PDF. Okay. And generate some content from this. So now how this is what developed. Okay. How this was done is if I just go back to the code, what happens is as usual, first I'm importing the Streamlit library as usual. I'm importing a library called as fits. Okay. Fits is by Python PDF. Why this fits is used? Because fits is a library in Python to extract text from the PDF. Okay. To work with PDF and to extract text from the PDF, you can use this. Okay. Extract text from the PDF. Okay. Text from the PDF. Okay. So this is used. And here you are installing a library called as OpenAI by OpenAI library itself, OpenAI company, and you are importing the OpenAI class, and I'm creating the instance of OpenAI class. Okay. Then here first I wrote a function called as extract text from PDF. So you can see I'm giving the PDF file as input, whatever I uploaded right now. And what it does is this bits.open will take this PDF file, it will read the content and it will generate the text from this. Okay. So this code is responsible for getting the text from the PDF. Okay. Whatever text, it will read the text. Okay. Automatically. But the main problem in this is it will only read the text which is in the electronic format. If you're having the PDF in the scanned format, this will not work. Okay. If you're having the text in the scanned format. For example, some PDF will be having scanned images, scanned PDFs. That will not work here. This is only for the text-based PDF. Means what is text-based PDF means I'll tell you. Okay. For example, if you see this PDF, if I'm able to select this, I'm able to select this text now. Can you see this? If you're able to select this text, this is called as electronic PDF. This is called as electronic PDF. This electronic PDF, it will work fits. But for scanned PDF, it will not work. Okay. For scanned PDF, you have to use OCR kind of systems. Like, any OCR you can use. Okay. Any OCR library you can use. Okay. So in that way, this is extracting the text. Okay. Bits.open will extract the text and it is extracting the text. You are getting the text. All the text in the form of merged. All the text is merging into one like this. You can see it is merging like this. Now after that, then I'll come to this function, get GPT response. So what is happening here is first I'm asking the user to upload the PDF file. Okay. So whatever, so I'm using Streamlit library here, Streamlit library file uploader and asking for the upload. Once you upload the file, so if the file uploaded, then what I'm doing, I'm first extracting the text from PDF, whatever function I just called. So I'm giving the file here and it is extracting the text from the PDF. Okay. You'll get the text here. Now, after getting the extracted text, then what happens is you're printing this message, right? You can see you're printing the success message here. Here, right? PDF uploaded and content extracted. You can start asking the questions. So I'm printing that here, right? After printing what we are trying to do, then we are actually initializing something called as conversation. Because if you look at this, the old conversation is also present now in this, like old question answer is also present. Now for saving that, I'm initializing something called as session state in the Streamlit to save the conversation. You can see conversation, all the conversations will be saved in this particular list. Then what I'm giving a text input. Text input is nothing but this, right? Text input is nothing but this one. This where you can ask your question, right? So then what happens after this? Yeah. So after this text input, it will ask a question. Now, the moment you enter some question here in this, okay, in the text input, if you enter a question and click on send button, so you can see there is a button called as send now. If you click on the send button, what I'm doing, if there is a user question, means if the user is asking the question, then what I'm doing, I'm putting in this list the conversation, let user and content, and I'm creating a spinner. That is the reason the moment you ask some question, you can see a spinner here, right? This spinner, like processing your question. That is because of this spinner, and it will send to this particular function called as get GPT response. Now, what this get GPT response will do is, it will take your context. If you see the get GPT response here, it will take your extracted text. Extracted text, your context means PDF and your question. The text from the PDF, and the question and your question. It will take this. And here I am using the OpenAI's client and I'm calling client.chat.completions.create. Okay, this is the function we have to use, and I'm calling GPT 3.5 turbo model. Okay, so GPT 3.5 turbo is the basic model. Okay, like if you want to use GPT-4, you can mention GPT-4 here. If I want to use GPT-4, there is also GPT-4o came into the picture now recently. If you have seen GPT-4o, if you want to use, you can use GPT-4o. It's completely your model. Means more and more model, more and more money. Means right now it is a free API, but API is cost. I'll show the pricing also for this API. How to create the API, I'll show you. But yeah, this is how you have to, means more and more better model you'll be using, more and more pricing will be there. Okay. Right now I'm using a very basic GPT 3.4 turbo. Then I'm creating a message here, and the message should be in this structure. That is, I'm asking this, I'm giving a prompt. You can see you're an helpful assistant. You have to actually, yeah, you have to answer questions about the given PDF like this. This is a given prompt. This is a system prompt. So basically in prompt, we'll be having two types of prompt: system prompt and user prompt. System prompt is a fixed prompt. Fixed prompt means like that is a standard prompt. We can say standard question. Like what is the standard question here? What is the standard prompt here? You're a helpful assistant. Your job is to give questions, give answers about the questions about the PDF. Now, in the user prompt, you will be giving the context. In this prompt only, you can see I'm arranging the context like this. Context, nothing but the extracted text, whatever extracted text, and the user question. Means this is a context. Context means the text, whatever you're having, whatever you're giving from the PDF, and the question, whatever you're having. So that one I'm giving, and I'm getting the return output. I'm returning that whatever whatever text it is generating, it is returning, and that text I am displaying here. That answer I'm displaying in this. Okay, that message only you can see markdown. The markdown format I'm representing. So I'm saying you, what is your question, and assistant, what is the answer. Okay, so that is the reason you can see you are getting like this, and assistant, what is the answer, like this. A simple UI kind of thing. The main function is this. The main function is this and this for extracting the text and for asking for the API. Okay, but right now, guys, this will only work if you configure the API key. Okay, there will be something called as API key. For every API, there will be something called as password kind of a key. API key is nothing but password kind of thing to call the API. If without API key, you cannot do that. How do you create an API key in OpenAI? I'll show you that. Okay, so how do you create means you can just go to OpenAI developer platform. Okay, you can just go to OpenAI developer platform. So here you can just simply say OpenAI API. So if you see the pricing guys, so initially they'll provide some free requests for you. You can use that. After that you have to pay. Again, I guess don't need to add any credit card, debit card, don't need to add anything. But for initial purpose, you can just use it for free. You can see there's a code and given to us. This code only we are working on. But if you see the models, yeah. So these are different models present. GPT-4o, GPT-4o mini, and all those things. And if you see the pricing, actually, somewhere you'll be having the pricing here. I just want to show you the pricing also. Yeah. Pricing, if you see for the API, the cost of the API means basically in this, why see we are using a closed source model. Closed source model means you are not loading in your GPU. See, if you are loading in a GPU, it is free. You have to pay for the GPU cost. That's it. If you purchase a GPU, you can put in your local only. That is free. But if you want to use some other API like OpenAI, because this model is hosted on the OpenAI's cloud, so they are basically charging this much. For GPT 4.0, if you're using there's a top model available. There's a top model. Okay, GPT 4.0. It is $2.5 for 1 million tokens. What is tokens costing? See, in NLP, if you remember, we talked about the concept of tokenization, right? Token means each word. Each word is a token, basically. Token means each word. So for 1 million tokens generated or 1 million input tokens, it is taking $2.5. Okay, and $10 for GPT. This is the latest model, I guess. This one, which is very costly. And audio, for audio model also. Audio. Right now we are using GPT 3.5, GPT 3.5 Turbo. If you just scroll down, you'll be seeing the pricing of GPT 3.5 Turbo. Yeah, here you can see. It is only, actually it should be less. What I'm seeing here. Okay, this is for fine tuning, not for fine tuning, for calling. That is what I'm saying. It should be less basically. GPT 3.5 is, basic model. For fine tuning, it will take a lot of time because fine tuning is training. You can provide your data and train. Okay, have to. GPT 3.5 Turbo. So somewhere you'll be having that. You can search for that. So you'll be having that. Yeah, that is the pricing. Okay. And if you want to create an API for yourself, and if you want to use it, I'll tell you how to use it also. If you want to create an API, you can just go to OpenAI developer link, and you can just log in first. Log into your account. Whatever account you're using for ChatGPT, you can use the same account. There is no change. Okay, so I'm just logging into my account. Okay, after logging to your account, okay, you should find something called as dashboard. Okay. You should find something called as dashboard. Here, if you click on settings, you can find that. And here, there is something called as API keys on the left side. API keys. So if you click on API keys, it will ask to generate a new key. So if you click on create a new secret key and give a name, like, for test or something. And if you want to select a project, you can select a project and click on create a secret key. So it will give a secret key for you. This is a secret key. Okay, key is very important. I've configured this key in my backend. Okay, this key is very important. Okay, done. So this is your key, which is very important. Okay, and when you generate a key, please copy it and put it somewhere, because that key will not show you the key again. It will show only for one time. So keep that key somewhere. And after doing that key, what you should do is after you copy that key, then what you should do is before you create the instance of OpenAI, you should do like this. You should say import OS, and you can just simply say OS dot environment. And here you can just write like this. You should create like an environment variable. OpenAI API key, right? OpenAI API key is equal to, you have to paste that key. See, I've already configured this key in the backend. That is the reason it's working for me. But for you, it should work. For you to work for learning purpose, I'm just saying OS.environment, and you have to paste your OpenAI key here, whatever OpenAI key you have generated. Then only it will work, or else it will not work. Okay, you'll get an error saying that OpenAI key not available or something. So compulsory you have to use like this OS.environment. You have to create an OpenAI key, and whatever key you copied from here, whatever API key you have created from the developer console from your account, here you can find in developer console. I've just open developer and click on settings here. You can find this, and here you can find API keys, and here you have to click on generate new key, and you can generate here. I mean, once you generate it, please copy it and put it somewhere. Okay. Then after that, you have to use that, paste that key here. After that, you can run this application and see. I guess with this key, it will work or not. I should check, because I've already used the free credits in this account. So I'll try once. In this account, I've already used free credits in the account which I'm working on. But let me try once. Let's say, hey. There will be some limitations actually. I guess some, if I'm not wrong, some $5 or something. Yeah, it says the same thing. For me, I already use this quota in my existing account what I have created. This is a different account actually. So it says, you can see it says you have exceeded your current quota. Please check your plan and billing details, because already I've exceeded. But you guys, if you're doing it for first time, some $5 or something, they'll give it, I guess, if you just check it out. Somewhere you can see the billing. In the billing, you can see you can see right now $0 available. I have exhausted everything. It is gone. But you'll be getting some free trial something. In free trial, you'll be getting some, some credits for you for practice purpose. You can use it. Okay. For the first time. After that, you have to pay, because we'll be using retrain models, and also you can create multiple accounts and do that, no problem. That advantage you're having for learning purpose, you can do that. That is not a problem. And it will not take, $5 actually is very huge actually, because you don't use much.
It's only work for a company, they don't manage.
Obviously. When you're working for a company, they'll manage all these things. You should just ask them for the key, that's it. The remaining thing they'll manage, like the costing and everything they'll manage. If you're using a closed source model, if you're using open source model, again, the company will manage to give you the GPU. For example, in our company, the company will give us the GPU. They purchase a GPU and give it to us. Our idea is to use that GPU, load all the libraries there and use it. Okay. I'll show that interface also. How to do that? I'll show that interface. Okay. In a later part of the session. Don't share that. No need. You can just use it for it. Whatever code I'll share, use that. I already have a key, separate key. That is the reason I was able to do that. Whatever key I pasted right now is the old key. Old key means the other accounts. But I have pasted a paid account key. That is my other account key. Whatever I am using, I pasted somewhere else. Okay. So because that's somewhat what we say, secret key, not a personal account key. That is the reason I pasted somewhere else, and I'm loading it here. So
similar thing for Twitter development.
Yeah.
Getting security.
Yes.
So three types of cookies were direction to analyze the tweets of
Correct. Similar way. Correct. Similar approach here also. Same approach. Call the API. For secure means OpenAI will understand that it is called from your account. To identify your account. See now this code, if you see where you are telling that you're calling from your account, they should know now. One for security, second for identifying you that this is your account. For every account, there will be a unique key. For my account, I'll be having my unique key, you'll be having your unique key. So you're using this function from OpenAI, but anywhere did you mention your user ID or password? No. You didn't mention your user ID, no. API, OpenAI key will, that's a key for password. For every API, there will be a password basically. A password. Security, it's like a security. Security, because no one others should call, not so if others are calling from your API, then if you are added your card or something like that, they start charging you. So it's like a security. And also second thing is it's like a identifying that you as a. Okay? Yes. We can also say that API key is also like a password for encryption kind of thing. For encryption. So multiple things. API key for identifying. Yeah.
PDF or can we ask out of the context question like number of images in the file table?
Right now, this particular content, whatever we are giving, if you let me do one thing, let me print the text here actually. Let me show you. It is only taking the text data. We are not extracting the images. If you are extracting the images, then we can do that. Okay. So we can do that. I'm not telling it is not possible, but in this code, it is not possible because we are only extracting text. If you see the text, I'll show you. Let me go back and refresh this and upload again. And you have created the API key. Just check the how much available, how much free credits you're having in the billing. See in the billing section. You will be finding the billing section. Okay, I guess we should do something for that. Let me find out. 0. Okay. Okay, fine. Let me see. Okay, fine. For your question, transformers.pdf. Huh? Okay. Yeah. Oh, fine. So you can see whatever PDF text is generated, you can see that text here. Okay. These are generated text. This text only we are sending to GPT right now. Now in this text, we don't have images or we don't have any kind of data. Now. I mean, whatever is images and tables. We don't have tables like structure also anywhere. I mean, we are giving like a text only, like a text structure only. That is the reason it is only looking at the text and it's trying to understand the text. But maybe if you give a images kind of structure, like maybe if you say this is the image, all those things, maybe it might answer. But let me see what it understood. Let me ask this question also for you. Like let me ask like how many images and tables you find. That is what my idea is also. Let's check. But whether GPT is able to identify or not, we should check. Okay. So how many images and tables you find in the extracted content? Okay, that are 5 images, attention visualizations, and 3 tables in the extracted content. Okay, maybe it is whether the structure it is trying to identify, I guess. So if you just look into the content, this is a content generated. Basically, for images, you'll be having like figure number 1, figure number 2 in the research paper, basically. So maybe that is that is one interesting idea it is looking into. That's a good thing. And moreover, you're using a top model, GPT, obviously top model, best model. So it will be able to identify, I guess. Yeah.
One question.
Yes.
Can I ask?
Yeah, please.
How is the title actually relevant to the paper?
That's a good question. So if I want to answer this question, attention all you need. Why exactly this name was named as attention all you need? Because attention is a mechanism actually. Like for example, whenever you're looking at any text translation, for example, I want to translate "I how are you." "I how are you." I want to translate it because this research paper is basically based on translation in this case only. Okay. So I how are you if I want to translate. "I how are you? What are you doing?" All these things. Now, if I give a long text string, so before seeing the answer, I'll tell you this answer. Okay. From what is actually happening. Okay. Imagine you're having a long text like this. For example, I'll just open lorem ipsum. Okay. So if you look at this long text here, see this long text. Now, given this long text for you to translate, for example, you're a translation expert of Hindi. Now, when you're given this long text, will you translate all the text at once? Will you able to translate all the text at a single go? No, right? First, you'll take first few words, and then translate. Then you'll take next few words and translate. And then you take next few words and translate. Your mind is not capable of translating, looking into all the text at once and translating. Even the transformers also is based on that idea. Attention is all you do. Means if you want to translate this text, what are the other text you have to attention? You have to keep pay attention on. Pay attention, we'll say. Pay attention. Pay attention on this topic. Pay attention on these words. So in order to translate this word or this words or this word, what are the other words? What are the nearby words? You should pay attention. Should pay attention on them. That is where the attention is already in paper was released. Pay attention means on what words you have to pay attention. Okay. Let's see what our bot says. Okay, now. Okay. Yeah. How it is okay. The title attention is all you need is relevant to the research paper because it highlights the main idea behind the proposed transformer models discussed in the paper. The paper introduced the new architecture transformers based on attention mechanism, eliminating the need of recurrent neural networks, and the title emphasizes the current role of attention mechanism in this transformer model, suggesting that attention alone is sufficient for highly quality results. Okay, it is not giving in a proper, not in an easier way. So maybe you'll say, how is attention always needed? Title relevant to the research paper. What is attention? Like, let's ask this and see what it says. Attention means here.
There is no answer related to the input correction. You are getting red line between I and S.
No. This is because I'm having Grammarly that extension. That's it. Not in the stream letter. Yeah, you can see attention is I just told you, attention is a context, refers to mechanism that allow model to focus on different parts of the input sequences when generating the output sequences. Different parts means, for example, if I'm translating the current word, what are the other words? What are the other contexts I have to pay attention on? Pay focus on. Attention means focus. Focus on. You can see different parts of the input sequence. Attention mechanism is a model to learn. Okay. That's it. So this is the idea. Okay. So any other questions? Anyone? Any doubts? So what you do is, I'll just share this file with you. This file is enough. So what you should do is you try to do it this today. Okay. I guess you're having how many credits you're selling now? 18 credits, $18.
Yeah.
Okay. Because I've done this very long back ago, I'm not sure what is the right now credits available for free account of GPT. We should check that. But however, you can try this out. But the concept is same. You have to import OS and place your OpenAI key here. Okay. Place your OpenAI key like this. Okay. Whatever OpenAI key was generated for you, please paste it here. Okay. That's it. To run this code in your system. And to run this code, you have to install pip install OpenAI. Okay. Obviously, pip install OpenAI to run this code, and obviously pip install Streamlit and pip install. Here, you should install pip install fits and 5 MB PDF. Basically, 5 MB PDF is enough. Okay. Pip install extract the text, and this one is pip install 5 MB PDF. That's it. So this, I already pasted the installation commands for these libraries. Install these libraries in your system and run this code. Go through this code. Okay. So this is the use case and this is the concept. So any other questions regarding this? Are we clear? Clear everyone with the concept of generative AI basic idea? Got the basic idea? Okay. So if you have questions, you can ask here right now, or if you are clear, you can close. I'll upload actually. I'll share in the group somewhere. I'm not uploaded anywhere. I'll be sharing. Yeah, we'll do that. Any other questions, anyone? Okay, then let's close. Thank you.
Tomorrow session online.
Online. Now we're also having deep learning session after this. After 20 minutes, like that, we'll plan 20-25 minutes. We'll plan deep learning session, and then tomorrow session will be online. Tomorrow session will be continuing the project. We are having an NLP project. We'll continue that. Okay. So thank you, guys. Thank you, everyone. Thank you.